4 today. So on section 1.4, which starts on page 26, that's where it's at. And some of the things that I want to point out to you that are on page 26, what we're going to do in this section is we're going to rewrite equations in different terms. So you're going to use these equations that you've used over last year, especially in geometry. You had multiple different formulas for like area and volume and stuff like that. Okay. That works. So then, if you look on page 26, there's a chart on there that gives you a bunch of those formulas. I'm not going to require you to memorize those formulas, obviously, but I just want you to know that they're there for you if you need them. If you need to write them down, that's your choice. But the distance formula we will use, temperature conversion between Fahrenheit and Celsius we use, especially with where we're at in the world. 40 miles north of us, we are in a different country that uses Celsius, right? If you didn't know that, that's what Canada uses. Okay? I know me growing up playing hockey, we were in Winnipeg quite a bit, and so then we would have to know a little. That was before you could just punch it on your phone and change it, or your car and change it. Okay? So that is there, along with a bunch of area and circumference stuff. Okay? So if you need those formulas, feel free to write them down, but typically they're going to give you formulas or give you the equation anyway on which one to use. Okay? So what you're going to do is you're going to be given an equation or given a formula, and it's going to ask you to solve for a different letter. So if I give you something like the distance formula, so d equals r times t, it's going to say 4r, for instance, or 4t. It's not going to be in the same format that it was given to you in. So if I want to solve for r, I'm going to do the same process we did yesterday. Yesterday, remember, we get rid of adding and subtracting first, then multiplying and dividing, then exponents, and so on. Same thing here. Is there any adding and subtracting I need to get rid of? No. Is there multiplying and dividing I need to get rid of? Yeah. How do I get rid of multiply? Divide. What am I going to divide by? The letter t, right? So if I divide by t to both sides, I end up with r equals d divided by t. And I'm done. That's what you're going to be doing for a lot of your assignment today, is solving for the equation for a different letter. Now, after that, it might say, find r if d equals 180 and t equals 3. So then it might say, find the rate if you know the distance and you know the time. So if I told you that d was 180 and t was 3, how fast were you going? On average, 60 miles an hour. Okay? Which is roughly how long it takes you to get from here to Grand Forks. Even though the speed limit is 70 for most of that, because you have to slow down through some towns. Okay? That's what you're going to be looking at today for a lot of your assignment. Okay, just to give you another one. Anybody remember what this formula is for? Perimeter. Perimeter of what? Rectangle. Good. It's the perimeter formula for a rectangle. It's 2L plus 2W is equal to my perimeter. So, going through the process again, is there any adding and subtracting that I need to get rid of? What do I do first? Subtract 2W. Good. So I have P minus 2W equals 2L. Now what? Divide by, not 2L, because you're trying to solve for L. No, not by L. Just divide by 2. We're just going to get rid of the piece that's not what we want to solve for L, so we want to isolate that variable all by itself. Okay? So we're going to divide by 2. Now, here's the part that I'm going to have to ask your opinion. Do you want to A, divide everything by 2 and leave it the way it looks? Or B, divide each individual piece by 2? Sierra, what do you want to do? Don't know? So option A, which is just divide everything by 2, or option B, each individual piece by 2. Is that the way you want to do it?
I don't know.
You think? You don't know? Hey, Sierra? There wasn't a wrong answer. You could have done it either way. Okay? So for this particular thing, if I'm dividing by 2, that cancels out. One of the ways you could leave it is just like this. That is perfectly acceptable. You could have P minus 2W divided by 2. That's fine. The other way that Sierra wanted me to do it was she wanted me to do each individual piece by 2, which would have looked like this then. P divided by 2 minus 2W divided by 2. The only thing with that is now you have an opportunity to reduce. Over here, this piece doesn't reduce. P divided by 2, can't do that. But this piece right here, what's 2 divided by 2 equal? 1. So then all of a sudden now I have P over 2, or 1/2 P, minus a W equals L. These two equations, this one here and this one here, are equivalent. They are equal to each other. Which one you have doesn't matter. Okay? But I am saying this to you now, juniors, that when you take your ACT or the Common Core test, it'll more than likely have the one that's on the right. It'll probably do both, the one where it divided each out. Now, where you guys screw up, on this one especially, is you just divide the 2's out and leave the P all by itself, and then all you have is P minus W, which is not right. If you have one bottom like that, you need to divide each individual piece if you're going to reduce it. Okay? This one over here on the left, that can't reduce. You leave that alone. Unless they all have something in common, leave it alone. Does that make sense? Alex?
Is that 4L?
What 4L?
Down the top, like below.
That's how the problems are going to look. It's going to give you an equation, or give you a formula, and it'll say for this letter. So it wants you to solve for that letter that it says after that. So it might have said, given you that one, and it might have said 4W. So it'll tell. I'm trying to tell you what letter to solve for. Okay. What do you guys think? Not too bad so far? Okay. Then after that, what they're going to have for you is they're going to have ones that have, and you're going to do this more often than you think anyway. (9x minus 4y equals 7, 4y). You have done this in your Algebra 1 class. You have solved for y before. The reason why you solve for y, and most textbooks have that, is because the invention of these, up in the upper left-hand corner up there, that says y equals. So we're going to get pretty good at solving for y, because we're going to have to be throwing these in our calculators eventually. And it has y equals. So that's what it's going to want you to solve for. It's also for graphing purposes. We want to get it in that slope-intercept form that we're going to deal with later on. Okay? So, what's the first thing I need to do for this one? If I want to isolate the y, or get the y by itself, what's the first thing that needs to move? Subtract 9x. I'm glad you said that. And the reason why I say that is because a lot of people say add 9x. The reason why they do it that way is because they look at the sign that's written up there, which is the negative in between the 9x and the 4y, and they think that I have to do the opposite of that, which is not right. It's the opposite of what's in front of the x, which in that case is a positive. So now I have negative 4y equals negative 9x plus 7. Now, going back to what I asked Sierra a few minutes ago as far as which way she wanted me to do it, she said individually, that's the way I suggest you do it for these. When you're solving for y, it's usually for graphing purposes later on. So you want to solve for each individual piece, or you want to divide it by each individual piece. The reason for it, because this particular graph is a line, we need the slope and the y-intercept eventually. So you're going to want to do each piece just like she had suggested on the last one. Okay? So when you're dividing by 4, you divide to everything that is on the other side. Remember, now terms are separated by adding or subtracting. So we could have had 3 different ones or 4 different ones depending on if it's a bigger graph or not. So when I simplify this up, those cancel out, so I get y equals, what did 2 negatives make? A positive. Now, one thing that I want to warn you about, last hour, they made the connection here where they said, well, that's 1.75. What they did was they took 9 divided by 4. No, it's not. I was looking at the last one. That's 2.25. Okay? And so that's what they had it as. Me personally, I would stay away from decimals with this stuff because of the fact that decimals, a lot of the times when you get a decimal, they're going to be ones that never stop or they repeat. And especially for this particular case, when you're looking to graph this, using slope, decimals are harder to work with than improper fractions. So unless you can reduce 9 over 4, just leave it alone. So 9 over 4, because when we go to rise over run, that's up 9 over 4, and I'm way faster than a decimal. It's not wrong if you put it as a decimal. I'm just saying that for now it might be easier just to leave it. Okay? I'll take it if you give it as a decimal, but leaving it is probably an easier option. What's 7 over negative 4 reduced to? Negative 7 over 4. Or negative 1.75 or negative 1 3/4 or whatever. That's totally up to you. And we're done. Now the only other thing that they might do for you is they might say, then find y if x is 16. So what do they want you to do? So plug 16 in for x and see what you get. Okay? What do you think? Have you done that before? I'm sure you have in your Algebra 1 classes. I'm sure you've solved that. That was in what they consider standard form because you have x and y on one side and the number on the other. And then you solve for it to graph it, I'm sure. Okay? Then the only other type that you're going to see are ones that look like this, where you have 2y plus xy equals 6 for y. If I want to solve for a variable that's in 2 different locations, the first thing that should happen, which I already did for you, is you should get all the letters that we're trying to solve for on one side or the other. So what I mean by that is if I'm trying to solve for y, which I am, then all the y's need to be on one side and everything that doesn't have a y needs to be on the other side. I already set that up for you in this case where all the y's are on the left and non-y's are on the right. Okay? Now you're going to do something that you guys probably spent about a month on in Algebra 1, and that's called factoring. You guys remember factoring? Factoring is nothing more than undoing the distributive property. That's all it is. So what I'm going to ask you is, looking at the 2 terms on the left, what do they share in common? A y. Right. If I take a y out, what's left over? So if I take a y out of the first one, what's left over? A 2. And if I take a y out of the second group, what's left over? X. Good. You just factored. Yay. Nice job. So now how do you get rid of a times by that big group? Don't subtract it. What's the opposite of multiply? Divide. So now we're going to divide everything by that big group. Now, if you notice, sometimes I'll put it in parentheses, sometimes I won't. Okay? It's up to you whether or not you keep the parentheses around it. That's totally up to you. It's not wrong if you do, and it's not wrong if you don't. But these cancel each other out right here, which is what we want. We wanted to get the y by itself, which you did. And then on the right-hand side, now I have 6 over 2 plus x. Here's what you don't do. You don't tell me that that's 3 over x. Or 3 plus 6 over x. That's not right. Okay? You cannot reduce just one piece. You can't go one piece like this and then not here. Because these two are joined together, it has to be where you have a 2 plus x on the top with a 2 plus x on the bottom in order for you to reduce it. So this right here is the right answer. You cannot reduce those two. If there's only one piece on the bottom, like there would have been for Sierra's -4, then we could do it. But if there's 2 pieces or more on the bottom, you can't unless that matches one that's on the top. Just leave it alone. Don't be a hero. Don't try to go further than what it has to be. Okay? You're going to have about 2 or 3 that are like that, where you got to get all the y's to one side, anything that's not a y to the other, factor it out, and then divide. And once you do that, you're done. Now again, the last little piece might be find y when x is 4. So then you put 4 in for x and see what you get. I did not give you a word problem, much to your, chagrins for this section. I didn't give you a word problem today, sort of. It gives you the formula, so it's not really a word problem necessarily. Not like you have to make one up like we did for 72. Okay? So if you go to page 30, just to kind of talk you through everything, on page 30, we start with number 4, and it says solve A equals 1/2 BH for B. Then find the base of the triangle with a height of 6 inches and an area of 24 square inches. It's just telling you to solve for the other letter and then put the numbers in and see what you get. Number 6 is multiple choice. You're taking the area formula of a trapezoid and you're trying to solve for B1 and see which one it matches. 8 through 14 says solve the equation for y, then find the value of y for the given value of x. So solve it for y, then tell me what it is when you put in like 8 or -3 or whatever. Then 16 says describe and correct the error in solving the equation for y. That person screwed up somehow. Tell me how. What did they do wrong? Okay? Then if you look on the next page, 18 through 20, gives you the formula, and there's one of the letters are in red. Solve for the letter that's in red. Then plug the numbers in and see what you get. 22 to 26 has x's and y's, and it's going to say solve for y. And then plug in the value for x. Same thing with 28. And that's as high as we're going to. So on page 30 to 31, or 4 to 28, evens. Evens.